Good morning to one and all. I am Parthiban, working as an assistant professor in the Department of ECE, Sri Muthukumaran Institute of Technology, Mangadu, Chennai. Now I am going to talk about the subject called satellite communication, which is coming under the regulation R 2021. The subject code is CEC 352. We are going to see about the various link power parameters and its effects on the service quality. Naturally, there is uplink as well as downlink. So uplink is nothing but the transmission from earth station to satellite, whereas the downlink is from satellite to earth station, that is called downlink. Generally, uplink will always have the higher frequency compared to downlink. Downlink will always have the lower frequency. So there are factors that affect the satellite system design also. Before that, the various uplink parameters are there that we are going to see. For example, in the uplink, we are going to estimate the EIRP, that is equivalent isotropic radiated power, as well as the uplink pattern advantages also we are going to see. Then the transponder gain that plays a very important role. In the downlink, we are going to see about the pattern that we are going to have, as well as the receiver antenna gain. In between the path or medium, we are going to see about the factors that involves, particularly the free space losses, the waveguide losses, the atmospheric losses, the rain attenuation, as well as the tracking errors. So in terms of intermodulation techniques, we are going to estimate the ES intermodulation effects, as well as we are going to see about the uplink thermal noise as well as downlink thermal noise also. There will be a transponder intermodulation effects will also be there. There will be some co-channel interference effects also will be there because of the similar frequency that we are going to use. So these factors or parameters all will be considered and it will take into account. There are generally four factors that involves related to the satellite system design. The first one is the weightage of the satellite. The next one is the choice of the frequency. The third one is atmospheric propagation effects. And the fourth one is the multiple access techniques. So the major frequency band that we are using are 6 bar 4 gigahertz, 14 bar 11 gigahertz, and 30 bar 20 gigahertz. So generally uplink frequencies will always be higher because the uplink involves a lot of hurdles for propagation of signals. Whereas the downlink is somewhat quite easier. That's why we are using the lesser frequency standards. Generally, we use the minimum space to avoid interference. So the link budget determines the antenna size. The link budget generally deals about the power requirements, link availability, bit error rate, and the overall customer satisfaction. So all the things will be taken into account. If you go with the weight of the satellite, generally weight is very important because the launch cost depends on the weight. Larger satellites requires larger launch vehicles. The fuel requirement also increases. The structural requirements become more complex. So basically for this we have to need to reduce the weight and optimize the power. Generally, lighter satellite may carry a small antenna with larger power requirements. The next important one is the choice of the frequency band that we are using. Since the operating frequency determines the antenna size as well as the atmospheric losses, as well as the available bandwidth, as well as the system cost. So generally the uplink and downlink frequencies are very important. So for satellite communication, we use C band, KU band, as well as the KA band. These are the predominant bands that we can use. Generally, the third factor, important factor, is atmospheric propagation effects that involves the rain attenuation as well as the cloud attenuation as well as the atmospheric gas absorption. So these are the major factors that we have to take into account. Similarly, the tropospheric scintillation also plays a very important role in fading as well as signal distortion. So the ionospheric effects also will be considered because the ionospheric effects like the Faraday's rotation, the delay, the scintillation will also be taken into account. Generally, the fourth important factor that will also have the major effect on link power budget is the multiple access technique. So we are going to use many users per satellite. So many users, many satellite channels can be operated at a time, so that the users can have the wide variety of channels. So for that we need a multiple access technique. So that may be in terms of frequency, that may be in terms of time, that may be in terms of code division, or that may be in terms of space division. So there are four major types of multiple access techniques are there. The one is FDME, CDME, TDME, as well as SDME. So all the factors must be considered into account before designing a satellite link. So satellite link is primarily consists of three segments. One is called the transmitting earth section. The next one is the satellite section. The third one is the downlink section. So these three sections taken into account, and the three losses also be taken into account. So the link budget is nothing but a establishment of a CN ratio, which is the simplified calculation that is for estimation that we are using. So evaluation of the received power and noise power is very important in any radio link. The link budget must be calculated for individual transponder and for each link. When a bent pipe transponder is used for uplink and downlink, the CN ratios must be combined to give an overall CN ratio. So CN ratio is nothing but the carriers to signal noise ratio. It should be as high as possible to provide a very good quality of signal. There are so many link budget examples that we can give. Basically, a satellite engineer needs to assess and allocate the performance of each source of gain and loss. The link budget is the most effective tool or means that we can have for a power balance equation, which is expressed in terms of decibels. So the satellite engineer has to create a personalized methodology and format for their own link budgets. So problems may arise when link budgets are exchanged between the engineers, and the formats may vary, but the standard link budget software tool can be used to access the calculations as well as the values in a clear. So link budget gives a primary contribution for the satellite designers, which gives we can say an accurate estimation of the signal strength as well as losses, as well as what type of transponders we can use, what type of antennas we can use, what type of signal strength we have to use for uplink as well as downlink. So these all the factors are combined in a single table by means of link budget example, which will give clearly the strength needed with mathematical equations as well as very accurate measurements and estimations. So which is a very important thing in the satellite communication design is link budget estimation. So with that, I am winding up my lecture. Thanking you one and all for hearing this patiently. Thank you one and all.